The Do More makes troubleshooting the Ethernet I/O system simple. You just keep an eye on this guy right here. That's your Do More check engine light. If something goes wrong anywhere in your Ethernet I/O system, this will be your first indicator. For example, suppose we have a bad Ethernet connection right out of the master. I'm going to reach down and pull the master's Ethernet cable, and sure enough, the check engine light immediately turns red. Well, I just click on that, and it brings up the system information, which tells us at a 50,000-foot view that there's an issue with the Ethernet I/O system. I just click on the I/O System View button, which is conveniently colored red to prompt me that this is what I want to do next. That brings up the I/O System Monitor, which gives me a detailed view of the entire system, including the Ethernet I/O master and all of its slaves. And sure enough, the Ethernet I/O master is colored red, and so are all the slaves. That's a pretty good clue that we have no Ethernet communications, right? I'll plug the Ethernet cable back in. The Do More automatically recognizes the issue has been resolved and turns off all the error indicators. We're good to go. Now what if an individual module in a remote slave has an issue? I'm going to disconnect the power to this analog module right here. This time my check engine light is yellow, a warning. What do I do now? Well, same thing. Click on the indicator. Brings up our high-level view telling us there's an issue with one of the I/O masters. And again, now this button is conveniently highlighted to remind me that's what I want to do next. I click on that, and up pops my I/O system view, and I can see that this master is reporting that this slave has an issue with this module. If I click on that module, then over here in the right-hand pane, it tells me what module it is, what addresses it's occupying, and there's an error message here. You can see it scanning through all the channels. It's telling me every one of the analog channels has failed. Well, that's a pretty good indication if something's wrong with the whole module. And of course, in this case, it's me because I disconnected the power. I'll reconnect that power, and after the Do More has made sure all the channels are back online, it automatically clears the warning for us. Now, what if I have a power loss at a remote base? Let's remove the power from this terminator base. Well, same thing. Our check engine light lights up red. We click on that. We get the 50,000-foot view telling us there's something wrong with our Ethernet I/O system. We click on the button that's already highlighted for us, and we instantly see that this master is reporting that this slave has got a problem. We click on that, and it tells us that the slave has a timeout error. The slave is not responding at all. So now we know we need to go figure out why that slave isn't talking to us. So how cool is that? Whenever there's an error in the Ethernet I/O system, you just click on the indicators and drill down as far as you want to figure out what the issue is. Easy. Did you notice that when I unplugged the power to the terminator slave, the master PLC got kicked out of run mode? What if you have a slave that's not critical to the operation of your system? Can you change things so that an error on one slave doesn't shut down the whole system? Sure. If we go back to configuration, Ethernet I/O master, and let's fix that terminator. I'm going to double click on him. Look, right here, I can say the CPU remains in run mode on slave error. We can also specify that the slave has to be OK in order for the master to be allowed to enter run mode in the future, and what we want to do with the inputs on error. I like to hold the last state so that I can go in and see what they were doing when the system crashed. OK, well, let's try this one. Again, if this slave crashes, the CPU should remain running. Let's try that. I'll say OK. I went ahead and plugged that slave back in so there aren't any errors when we start. We'll say OK there. Write this new configuration out to the PLC. Let's go ahead and get the PLC back in run mode. Remember, it got kicked out when we had the error last time. I can see here that we're running and that the PLC is OK. Let's go ahead and remove the power from that terminator slave. And sure enough, we get an error, but this time it's only a warning. It's not the red error. And the PLC is still running, exactly what we wanted. Now let's check the other condition. If I take the PLC out of run mode, he's in program mode, and then try and bring him back, what happens? It doesn't come back. Remember, we selected that option in the dialog that the terminator slave has to be fixed before the PLC will be allowed to re-enter run mode once it's been taken out. So again, exactly what we expected. If I plug the power back into the terminator slave, wait for the error messages to clear, and now try and put the PLC back in run mode, it works exactly as expected. Perfect. Note that while we've been using the Do More Designer to do all this debugging and diagnostics via the check engine light, you can also do it programmatically. There's a new Ethernet master error flag that's basically the status of that check engine light. There's also this Ethernet I/O master structure which has this general error flag too. It's very similar to the Ethernet master error, but just to be sure I don't miss anything, I check both, and if either one's active, I then go ahead and launch some kind of Ethernet I/O diagnostic program. That program would then walk its way down through this structure and use that information to figure out where the error is in the system. These are all the same bits that are driving the red and yellow stuff that we saw just a moment ago. So you can do the same kind of stuff we did back there, but in your ladder code. How about that? One last thing to keep an eye on is the polling rate of each slave. If the slave is not a high priority, then consider slowing down the polling rate to open up the Ethernet bandwidth for other devices. How do you do that? Easy. Go back to Configuration, Ethernet I/O Master, click on the slave of interest, and right here you can set the polling rate to anything you want. This slave is not a high priority for me, so I have it only updating once a second. Now, if you want to see who's using all the bandwidth and how each slave in your system is doing, then check out the Ethernet I/O Monitor. You can reach out under the Debug menu, Ethernet I/O Monitor. In this dialog, you see the general Ethernet statistics for the entire system and what each slave is doing. Now remember, we set the Terminator I/O slave to update once per second, right? Well look, we can see that right here. These guys are updating like crazy, but this guy's only updating once a second. You can also see retry counts and configured retries, last error code, all of which were generated back when we unplugged that module, of course. And then over here you can see the rate that you specified for each module. This guy specified to update once a second. These guys are specified to go just as fast as they possibly can. If I pull an Ethernet cable on one of them, then we can see the error right here. Put it back, the error clears, and if we want to restart the error codes and the counts, we just click on these buttons here. Nice. You can even go straight to the I/O system view, the Ethernet I/O master, or copy all these statistics to the clipboard so you can email them to a coworker or even tech support. Be sure to check out the other Do More videos in this series for more ways to get the most out of your Do More system. And don't forget, if you have a question, you can reach Automation Direct's free support via phone, email, and live chat during regular business hours. Spend less, do more from Automation Direct.